Hello everyone, welcome to another video. So this video is about some analytical calculation regarding mathematics. So basically we'll discuss about double integral. Now in different modeling involving mostly multiphysics modeling, you might need to calculate integral across a surface, across some curved surface, maybe integral above a volume, line integral, and so on. So in all these cases, we might encounter different integrals and averages. So in this video, we'll discuss about double integral. Now, in the world of science and engineering, we often need to calculate how certain quantities accumulate over an area or even a volume, whether it's determining the total heat across a surface, the mass of an object with varying density, or even the flow of fluid through a pipe. This kind of problem aren't always easy to solve with simple equation. That's where double integrals come in. Double integrals are a powerful tool in numerical modeling, allowing us to compute complex quantities over two-dimensional regions. From understanding electromagnetic field in physics to optimizing designs in engineering, mastering double integral is crucial. We'll try to take an example and actually solve and get the values. Now the basic understanding is needed according to me when you are working on complicated problems. Only then you will be able to actually understand and fix any error or issues that you might face while doing the post-processing or actually solving the model. So what is a double integral? A double integral is an extension of a single integral used to compute quantities over two-dimensional regions. It allows us to integrate a function of two variables, say f of x and y, over a specific area in the xy plane. Mathematically, we can write it as double integral. The two symbol actually represents the double integral over a region R, f of x comma y, and then dx and dy. Here, if you look closely, f of x and y, this is the function of two variables, and here R is the region over which the integration is performed, and the dx and dy represents the small change in both the x and y direction. Think of double integral as the way of summing up an infinite number of small areas or volumes. In one dimension, an integral calculates the area under a curve. In two dimension, the double integral calculates the volume under a surface where each element contributes to the total volume. For example, if you imagine a curved surface over a region R in the plane, the double integral helps us to find the total volume trapped between the surface and the plane by adding up small volumes over the region. Why use double integrals? Double integrals are crucial because they allow us to calculate area and volume, solve real-world problems, and also describe continuous distributions. So for example, when we talk about areas and volumes, one of the most basic use of double integral is to compute areas in 2D and volumes in 3D. Now, when it comes to real-world problems, it is widely used in physics and engineering in different problems. For example, the problems might require calculating quantities such as mass, charge, heat, etc. Similarly, in continuous distribution, double integrals help when dealing with continuous distribution of physical quantities like density, temperature, or pressure over a surface, and so on. So let us take an example of a geometry shape and then try to calculate the double integral manually. Okay, so let's see how we can do and actually solve this kind of problem. So imagine I have a shape like this, and I will just write the coordinate. So let's say this height is 2, and even this side is 2 units, and this is, let's say, 4. So the height is 4, and this is 2, and this is 0. Okay, and let us say that the double integral looks something like this. So we have region over R, and we have f of x comma y dy dx, and the bounded region is x equal to 0, x equal to 2, and we have y equal to x and y equal to x plus 2. So this is the square region. So we have x equal to 0 to x equal to 2, basically this region, and then we have y equal to x, so this is basically this line, and then y equal to x plus 2. So this is the area that we are actually talking about, and we need to calculate the double integral in this region. So let's start by writing the integral I to be the double integral, and we have the function x plus y dy dx. So here our function is given by x plus y. Now, depending on whatever problem you are using or working, you will have the function accordingly. So for this example, I'm just taking x plus y for simplicity. Okay, so then we can write I as, since the limit of x is 0 to 2, so we have 0 to 2 dx, and then we have integration of x to x plus 2 x plus y dy. Right now, if we try to solve this, so this will be like 0 to 2, and then if we integrate the inner part, we have xy plus y square by 2, and then the limit is x to x plus 2 dx. Now let's simplify, so I'll just use a new page. So this is 0 to 2, and then if we add the upper and lower limit, so it will be x plus 2 plus half x plus 2 square minus x square minus x square by 2, and then dx, right? And if we simplify, we have 0 to 2, and then we have x square plus 2x plus half of x square plus 4x plus 4, basically solving this part. Then we have minus x square by 2 dx, and then this actually simplifies to 0 to 2, and then most of the things get cancelled, so this half will get cancelled, and then we are actually left out with 4x plus 2 and then dx. So then this will be, if we take 2 as common, and then the integral will be from 0 to 2, and then we have 2x plus 1 and then dx. And so this will be 2, and this will be x square plus x, and the limit will be 0 to 2 after integration, and this will be 2, so 4 and 2 6, so 2 times 6, and this will be 12. So if I write the integral, basically the double integral of x plus y dy dx in the region R, I mean the region that we defined as the shape something like this, so that value came out to be 12 from our double integral. So let's see if we are getting exactly the same value when we are doing this in the software. So for demonstration, I'll be using COMSOL Multiphysics. So let's jump into the software and see if this is actually working. Hello, so we are in COMSOL and we'll try to calculate the double integral in the software itself so that you get an idea how the value actually compares when we are doing analytically as well as in the software. So I'll just create a blank model and let me just create a 2D component because we are just drawing a simple 2D shape. So in the geometry, I'll go on to polygon because I'll just draw the points and that will actually create the solid. Okay, so let me just write the point. So if you remember, it starts from 0, 0, and then we have 2, 2, and after that, so it runs from 2 to 4, and then from 0 to 2 again. So this is what we have, and we can again write 0, 0, but I think that is not needed. Now, as you can see, we have this solid. So these points actually represents these red circles. So if you just click on these points, you will have the visual representation of those points. So this is the shape that we have got. Now if I want to create a double integral, there are many ways, but one of the easier ways is to use the feature that is available in the definitions, right? So what I will do, I will just create a integral. Okay, so that is the first thing that I'll try. So I'll go to integration and I'll select this domain. So when you create an integration, you have different options. So for now, I'll select the domain because we are interested in this region. Okay, and then what we will do, we'll create a variable, and let me name the variable to be int integration of the region. Okay, now what we want to do, we want to also create a function. So let me first create a function f, and that function is x plus y. So you don't have to actually define what is x and y. So these are like system variable by COMSOL. So it actually takes the value of x and y. Okay, and in the integration, what we will write, we'll use the integration and then we'll write f. So this is basically the integral of the function f. Okay, and since we are integrating in the domain, so this is basically 2 dimension, so we don't have to manually write anything. Okay, let's see how we can actually get the value. So one of the easier way to get the value is we can add a empty study. So we'll just click on the empty study inside the study tab and then just click on add study. So you'll see that we have an empty study added, and I'll just click on compute, and if I go to results, and in the results, if I just click on the derived values and click on global evaluation, and I'll just keep I'll just try to type int. So you can see this is the integration that we actually created. So I'll just double click to add the expression, and you can see the unit. So it is meter cube simply because we have like the dx, dy and the x plus y. So it is basically 3 distance unit. That is why it is m cube. Now if I click on evaluate, it should show us the value. So as you can see, the integral value is 12.00. It is same as the value that we got from the integral that we calculated manually of this same design. So if you remember, this is x equal to 0 to x equal to 2, and then we have y equal to x, so this is 45-degree slope, and then y equal to x plus 2 because this height is 2. So this is x equal to 0, x equal to 2, this is y equal to x, and this is y equal to x plus 2. So this is the same shape that we created, and this is how we actually get the integral value, basically the double integral. And this is how you get the evaluated value in the table, and you can always copy and do your analysis whatever you want. So I hope you got some idea both how to solve it analytically and how to solve it numerically. I hope this helps. So if you like this video and if you want to see more videos related to fundamentals of how equations work, how to solve it analytically and so on, please do let me know in the comments, and also support my work. If you're really enjoying the videos and learning something, feel free to drop a mail if you have any query or if you want to share any information. Thanks for watching and have a nice day ahead.